Hello, now I'm going to explain you about it. Coulomb's law. Generally, this Coulomb's law was introduced by Colonel Charles Coulomb. So, coming to the statement, the force exerted between 2 point charges which are placed near to each other. So, nothing but whenever you consider 2 point charges and which that 2 point charges are placed near to each other, and what is the force applied between the 2 point charges is nothing but your Coulomb's law. So this is the statement of your Coulomb's law. And first of all, if we here we have to know what do you mean by a point charge. So point charge is nothing but it has a very small dimension. Generally it has a only location but not the dimensions. So whenever you place the 2 point charges near to each other, so if they are of like charges, there may be a repulsive force will be occurs, and if they are of opposite charges, so there may be a attractive force. So this Coulomb's law states that the force applied between those 2 point charges. So to find out that force, here I am taking 2 point charges, namely Q1 comma Q2. Those are separated with the distance of r. So here whenever these 2 point charges placed near to each other, we don't know this may be a positive charge or negative charge, or like charges or unlike charges. So whenever you place these two charges, so there may be a attractive force or repulsive force. So here we are going to find out that force equation. So for that purpose, here we are considering 2 point charges, namely Q1, Q2. So Q1 exerts nothing but applies a force on Q2. Similarly, Q2 applies a force on Q1. Okay. So we know that if they are of the same polarity, repulsive force will be there. If they are of opposite polarity, attractive force will be there. So mathematically the force can be expressed as F is directly proportional to the two charge particles, multiplication of the two charge particles like Q1 into Q2, and inversely proportional to the square of the distance between them. So if you remove this proportionality term, so the force equation becomes F is equal to K into some constant K into Q1 Q2 by R square. So here K is known as a constant of proportionality, and this value is generally is equal to 1 by 4 pi epsilon. And here we know epsilon is nothing but the permittivity of that material. So that permittivity generally it has a two parameters. One is absolute permittivity denoted as epsilon naught, relative permittivity epsilon r. So and we know this is the absolute permittivity is value is 8.854 into 10 power minus 12 farad per meter, and epsilon r value is 1 for A. Okay, or free space. So therefore K is equal to 1 by 4 pi epsilon naught into epsilon r. So for free space, this permittivity is epsilon r is equal to 1. So therefore epsilon becomes epsilon naught. So substitute that value here. K is equal to 1 by 4 pi epsilon naught into epsilon r. But epsilon r is equal to 1. So epsilon becomes simply this value. Upon simplifying this, like 1 by 4 pi into 8.854 into 10 power minus, we will get a value of 9 into 10 power 9 meters per farad. So therefore substitute that K value here. So F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. So F is equal to 9 into 10 power 9 Q1 Q2 by R square Newton per meter square. So this is the force equation. Generally with the force equation can be expressed in a vector form. So therefore vector form is nothing but it has a magnitude as well as a direction. So F is equal to F into AR. So whenever you consider 2 point charges placed with the distance of r, so whenever you are going to calculate the force from 1 to 2, so the force equation becomes F12 bar, which is equal to Q1 into Q2 by 4 pi epsilon naught into R12 square. The distance will be become R12 with the unit vector of A12. So A bar 12 is nothing but the distance vector R2 minus R1 by its magnitude. So this is R2 vector, this is R1 vector from the origin. So A12 becomes R2 minus R1 by R12. Similarly, F21 is equal to Q1 Q2 by 4 pi epsilon into R21 whole square into unit vector A21. We know that A21 is nothing but the distance between the two vectors 2 point charges, so it is R1 minus R2 by R21 whole bar. So and from these two we can write that A12 is equal to minus of A21. So from these two we can write F12 is equal to minus of F21. So we can say that the force exerted by two charges on each other is equal, but they are of the opposite in direction. Thank you.